In question 1, the coefficient of x power 4 in the expansion of 3 plus x to the power 5 is equal to the coefficient of x squared in the expansion of 2x plus a upon x to the power 6. We have to find the value of the positive constant a. Now, the expansion formula for a plus b to the power n is equals to a power n plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2 and so on. Now for the first expression, which is 3 plus x to the power 5, we only have x as a variable, which is b, so we need b to the power 4. So we can write this as 5c4, a is 3 to the power 5 minus 4, and b to the power 4, so this will be x to the power 4. 5c4 is 5, 3 to the power 1 will be 3, and this will be x power 4. So the coefficient of x4 is 15. And in the expansion of 2x plus a upon x to the power 6, we are looking for the coefficient of x squared, which means that in the numerator, we must have a power 4, and in the denominator, we should have power 2. So if we take a is equals to 2x, so we need 2x to the power 4. So as n is 6, we'll take nc2 again. So this will be 6c2, 2x to the power 6 minus 2, and a upon x to the power 2. 6c2, if we substitute this in the calculator, we'll get 15. So this will be 15 into 2 to the power 4. So 2 to the power 4 will become 16, x to the power 4 into a squared upon x squared. We can see that the x squared and x4 will cancel to give us x squared. 15 times 16 is equals to 240, a squared, x squared. Now, as the coefficients are equal, we'll equate to 240 a squared and put it equals to 15. To find a, we will write it as a squared is equals to 15 divided by 240. So if we simplify this, 15 divided by 240, this can be written as 1 upon 16. So the value of a square will be equals to 1 upon 16. Taking the square root of 1 upon 16, the value of a will be equals to 1 upon 4. Now, as a is a positive constant, when we take the square root over here for 1 upon 16, we'll only include the positive value and not the negative value. So the final value for a will be positive 1 upon 4. In question 2, the second and third term of a geometric progression are 10 and 8 respectively. We have to find the sum to infinity. Now, the nth term for a GP is equals to a r to the power n minus 1, and the sum to infinity is equals to a upon 1 minus r. So to find the sum to infinity, we need the first term and the common ratio. So as a second term is 10, we'll write it as 10 is equals to a r to the power 2 minus 1, which will become 1. And the third term is 8, so we'll write it as 8 is equals to a r to the power n minus 1, so this will be 3 minus 1. So 8 will be is equals to ar squared. Now we have two equations, 10 is equals to ar and 8 is equals to ar squared. Now from the first equation, we can take a is equals to 10 upon r and substitute this into the second equation. Substituting a is equals to 10 upon r, we'll get a is equals to 10 upon r multiplied by r squared. So r squared and r will cancel, and r will be is equals to 8 upon 10, which is equals to 4 upon 5. Once we have the value of r, which is 4 upon 5, we can substitute this over here to get the value of a. So a will be is equals to 10 divided by 4 upon 5, or we can also write this as 10 divided by 4 multiplied by 5. So this will be 10 multiplied by 5 upon 4. So 50 upon 4 will be equals to 12.5. Now we have the value of a and we have the value of r. We'll substitute this in the formula for sum to infinity. Sum to infinity will be now equals to 12.5 divided by 1 minus 4 upon 5. Substituting this value in our calculator, the sum to infinity that we'll get is 125 upon 2, or we can write this as a decimal, which is 62.5. In question 3, the equation of a curve is such that the dy dx is 3 into 4x minus 7 power half minus 4x to the power negative half. It is given that the curve passes through 4, 5 upon 2. We have to find the equation of the curve. To find the equation of the curve, we'll integrate the expression for dy dx. So first we can write it as dy is equals to 3 into 4x minus 7 to the power half minus 4x to the power minus half, and we'll take the dx on this side. Now integrating both the sides, so integrating dy, we'll get y is equals to integrating 4x minus 7 to the power half. The power will increase by 1, so it will become 3 upon 2 divided by 3 upon 2, and we also multiplied by the derivative of 4x minus 7, which is 4. Minus, so increasing minus 1 upon 2 by 1, so this will become positive 1 upon 2, and then we'll divide by positive 1 upon 2 and add a plus c. Simplifying this, we can write it, cancel the 2 and 4, and this 3 and 3 will also cancel out. So this equation will be written as 1 upon 2 into 4x minus 7 to the power 3 upon 2 minus, so this 2 will multiply in the numerator and become 8x to the power half plus c. Now to find the value of c, we'll substitute x equals to 4 and y equals to 5 upon 2. So 4 times 4 will be 16 minus 7 to the power 3 upon 2 minus 8, and then again 4 to the power 1 upon 2 plus c. 16 minus 7 is 9. So we'll write 9 to the power 3 upon 2. So 9 to the power 3 upon 2 will become square root of 9 is 3, and 3 cube is 27. Minus 8 times the square root of 4 is 2 plus c. Taking 27 upon 2 and 8 upon 2 on the other side, we'll get 5 upon 2 minus 27 upon 2 plus 16 is equals to c. 5 minus 27 is minus 22 upon 2. So this is minus 22 upon 2 plus 16 equals to c. Minus 22 upon 2 is minus 11 plus 16 equals to c. The value of c will be equals to positive 5. Once we have the value of c, we can just add it to the final equation. So the final equation will become 1 upon 2 into 4x minus 7. 4x minus 7 to the power 3 upon 2 minus 8x to the power 1 upon 2 plus 5. In question 4, the first, second, and third terms of an AP are k, 6k, and k plus 6 respectively. We have to find the value of the constant k. Now we know that in an AP, consecutive terms have a common difference. So we can write this as 6k minus k will be is equals to k plus 6 minus 6k. So the difference of second and first term will be equal to the difference of the third and the second term. This will become 5k is equals to, this is minus 5k plus 6. K minus 6k will be minus 5k. Taking this on the other side, this will become 5k plus 5k equals to 6. 10k is equals to 6. The value of k will be 6 upon 10 or 0.6. In part B, we have to find the sum of the first 30 terms of the progression. Now, the formula for the sum of n terms of an AP is n upon 2 into 2a plus n minus 1 into d. We already have the value of k, and the first and the second term were k comma 6k. Now the first term was k and the second term was 6k, substituting the value of k as 0.6. So the value of a will be 0.6, and the second term will be 6 into 0.6, which will be equals to 3.6. Now as the first term is 0.6 and the second term is 3.6, the common difference will be 3.6 minus 0.6, which is equals to 3. Now substituting these values in the formula, we'll get sum of 30 terms is equals to 30 upon 2 into 2a. So a is 0.6 plus n minus 1. This will become 30 minus 1 into d, which is 3. Simplifying this, I will get 15 into 1.2 plus 29 times 3. 29 times 3, if you substitute this in the calculator, that is 87. 87 plus 1.2 will be is equals to 88.2. So this will be 15 times 88.2. Multiplying it by 15, the final answer will be 1323 for the sum of 30 terms. So the total answer for sum of 30 terms is 1, 3, 2, 3. In question 5, the equation of a curve is y equals to 4x squared minus kx plus 1 upon 2k squared, and the equation of a line is y equals to x minus a, where k and a are constants. Given that the curve and the line intersect at the point with x0 and 3 upon 4, we have to find the values of k and a. Now, as we know, the point of intersection of for x is 0. So first we substitute 0 in both the equations. So when I substitute x equals to 0 into the first equation, that will become 4 into 0 minus k into 0 plus 1 upon 2k squared. And as they're intersecting, it means we can equate the y value. So we'll put it equals to x minus a. And as x is 0, that will be equals to minus a. So this will become a 0. We'll have 1 upon 2k squared equals to minus a. Or we can write k squared is equals to minus 2a. Now we'll substitute x equals to 3 upon 4 into both of the equations. So we'll get 4 into 3 upon 4 whole squared minus k into 3 upon 4 plus 1 upon 2k squared is equals to 3 upon 4 minus a. Simplifying this, we'll get 4 into 9 upon 16. So 4 will cancel with 4 over here, and this will become a 9 upon 4. We'll have 9 upon 4 minus 3k upon 4 plus k squared upon 2 is equals to 3 upon 4. And in place of a, we can write a as minus k squared upon 2. So in place of a, we'll get minus and minus k squared upon 2. Taking the LCM on both the sides, we'll get 9 minus 3k plus k squared upon. So this will multiply by 2 when we take the LCM. So as the LCM is 4, this will multiply by 2, and this will also multiply by 2. So this will become a 2k squared. Taking the LCM on the right hand side, the LCM will be 4 again. This will remain a 3. As this is multiplying by 2, this will also multiply by 2, and this will become a plus 2k squared. There is a common denominator on both the sides, so 4 and 4 will cancel, and this 2k squared will also cancel with 2k squared, as if you bring the 2k squared on either side, they will subtract and become 0. So when I cancel this out, this will be written as 9 minus 3k is equals to 3. So 9 minus 3 will be is equals to 3k, and the value of k will be is equals to 6 upon 3, which is equals to 2. So k will be is equals to 6 upon 3, which is equals to 2. Once we have the value of k, we can substitute it into the equation. We had this k squared is equals to minus 2a. So as k squared is equals to minus 2a and k is 2. So substituting k over here, we'll get 2 squared is equals to minus 2a. So 4 upon minus 2 is equals to a, and the value of a will be is equals to minus 2. In part B, it's given instead that a equals to minus 7 upon 2. We have to find the values of k for which the line is a tangent to the curve. Now, the equation of the curve was 4x squared minus kx plus 1 upon 2k squared. And the equation of the line was y equals to, so the equation of the line was y equals to x minus a. And in place of x, we can write, in place of a, we'll write minus 7 upon 2. So as it was x minus a, this will become x minus minus 7 upon 2. Taking the LCM on the left-hand side, we'll get 8k squared minus 2kx plus k squared upon 2. And this will be is equals to 2x plus 7 upon 2. So 2 and 2 will cancel out, bringing the 2x plus 7 on the left-hand side. This will become, this was 8x squared. So now the expression will be 8x squared minus 2kx. This 2x will come here and become a minus 2x plus k squared minus 7 equals to 0. Now we have a quadratic expression and an unknown constant. So we'll use b squared minus 4ac, the discriminant. And as it is the tangent to the curve, it means one point of intersection, which means we'll put it equals to 0. Now from the expression before, we'll have to figure out the values of a, b, and c. Taking plus x common over here, we'll get minus 2k minus 2 plus k squared minus 7. So the constant term over here is k squared minus 7, which is the value, which is c. So c is equal to k squared minus 7. The coefficient of x is taken as b, which will be equals to minus 2k minus 2, and the value of a will be is equals to 8. Now, once we have the value of a, b, and c, we can substitute this into b squared minus 4ac. So this will be minus 2k minus 2 whole squared minus 4 into 8 into k squared minus 7 equals to 0. Expanding this will become 4k squared plus 8k plus 4 minus 8 times 4 is 32. So this will be 32k squared, and 4 times 8 is 32, and 32 times 7 will be 224. So this will be a plus 224, as negative and negative will become a plus. Simplifying this, we'll get 4k squared minus 32k squared, which is 28k squared plus 8k, and 4 plus 224 is 228 equals to 0. We can substitute these values in the calculator or use the quadratic formula to find the values of k. When we substitute this in the calculator, this equation, so we'll get the value of one of the values of k will be equals to 3, and the other value of k will be equals to minus 19 upon 7. In question 6, the diagram shows the curve with the equation y equals to 5x power half and the line with the equation y equals to 2x plus 2. We have to find the exact area of the shaded region which is bounded by the line and the curve. Now, to find the area of the shaded region, in the first step, we need the point of intersection of the line and the curve, so we can have our limits for finding the area. Now, to find the point of intersection, we'll equate the two equations. So this will be 5x power half is equals to 2x plus 2. To find the value of x, we can whole square both the sides. So when I whole square the left-hand side, 5 square will be 25, and x to the power half whole square will be x. Expanding the right-hand side, this will become 4x square plus 8x plus 4. Bringing the 25x on the right-hand side, we get 4x square plus 8x minus 25x plus 4 equals to 0. Simplifying, it will become 4x square plus 17x minus 17x. So this will become a minus 17x plus 4 equals to 0. Now, solving the quadratic equation by middle-term breaking or using a calculator, we'll get 4x squared minus 16x minus x plus 4 equals to 0. Taking 4x common, this will be x minus 4, and taking 1 common, this will be x minus 4 equals to 0. So we'll get 4x minus 1 and x minus 4 equals to 0. The two values of x will be x equals to 4 and x equals to positive 1 upon 4. So now we have the limits for x. So the lower limit is 1 upon 4 and the upper limit will be positive 4. To find the area of the shaded region, we need to find the area under the curve and then the area under the line and then subtract the two areas. So we'll write area will be is equals to integral of the equation of the curve 5x to the power half. The limits will be 4 and 1 upon 4 minus the area under the line. So the equation of the line is y equals to 2x plus 2. And the limits will be 4 and 1. What we can also do is we can combine the equation to write it as 5x to the power 1 upon 2 minus 2x plus 2, and then apply the limits and get a final answer for the area of the shaded region. So when I integrate 5x to the power 1 upon 2, I will get 5x to the power. So increasing 1 upon 2 by 1, that will become 3 upon 2 divided by 3 upon 2 minus integrating 2x, that will become a 2x square upon 2, and integrating 2, that will become a 2x. So simplifying this will become 10 upon 3. So the 2 will go in the numerator. This will become 10 upon 3 x to the power 3 upon 2 minus 2 and 2 will cancel. So this will be minus x squared, and minus plus will become a minus. So this will be minus 2x. Now applying the limits, so the upper limit was 4 and the lower limit was 1 upon 4. Substituting 4 into the equation, we get 10 upon 3 into 4 to the power 3 upon 2 minus 4 squared minus 2 into 4. And then applying the lower limit, which we'll subtract from the upper limit, this will become 10 upon 3, 1 upon 4 to the power 3 upon 2 minus 1 upon 4 whole squared minus 2 into 1 upon 4. Now we can directly substitute this in the calculator as well. So 10 upon 3, 4 square root will be 2 and 2 cube is 8. So this will be multiplied by 8 minus 16 minus 8 minus 10 upon 3. The square root of 1 upon 4 will be 1 upon 2 and 1 upon 2 whole cube will become 1 upon 8 minus 1 upon 16 minus 1 upon 2. So this will be 80 upon 3 minus 24 minus this will become 10 upon 24 minus 1 upon 16 minus 1 upon 2. Opening up the brackets, we will get 80 upon 3 minus 24 minus 10 upon 24 minus 1 upon 16 minus 1 upon 2. Substituting these values in the calculator, the final area will be 45 over 16, or we can write this in decimal as 2.8125. In question 7, the diagram shows a sector OBAC of a circle with center O and radius 10. The point P lies on OC and BP is perpendicular to OC. Angle AOC is given as 1 upon 6 pi and the length of the arc AB is 2. In part A, we have to find the angle BOC. Now, as angle OBAC is a sector, so OAB will also be a sector. In this, the arc length AB is 2 and the radius is 10. So using the arc length formula, S is equals to r theta. The arc length is 2 and the radius is 10 multiplied by theta. So theta will be 2 upon 10, which is equals to 0.2. In part B, we have to find the area of the shaded region BPC, giving our answer correct to 3 significant figures. Now, to find the area of the shaded region, first, let's take the diagram to part B. So, taking the diagram to part B first. So now, to find the area of the shaded region, we have to first find the area of the sector, so and then subtract the area of the triangle OBP. So area of sector OBC will be equals to, the formula is 1 upon 2 r squared theta. Now this angle is 0.2. So the total angle will be 1 upon 6 pi plus 0.2. So we'll write 1 upon 2 into 10 squared into 1 upon 6 pi plus 0.2. Substituting this value in the calculator, the area of sector will be equals to 36.18 cm squared. Now to find the area of the triangle, we can first find the length OP and the length BP and then use area is equals to half base into height for the triangle. So first finding the length OP, as it is adjacent to the angle, so we can use cos theta. Now theta will be pi upon 6 plus 0.2 is equals to OP upon 10, hypotenuse is 10. So OP will be equals to 10 into cos of pi upon 6 plus 0.2. We have to make sure that our calculator is in radian mode as the angle is given in terms of pi. To find the length of BP, we will use sine as BP is opposite to the angle. So sine of pi upon 6 plus 0.2 will be is equals to BP upon 10. So the length of BP will be is equals to 10 times sine of pi upon 6 plus 0.2. Finally, to find the area, we'll use the area formula for triangle, which is half base into height. So we'll write half into 10 into sine of pi upon 6 plus 0.2. And this will multiply by the base, which will be OP. So we'll write it as multiplied by 10 into cos of pi upon 6 plus 0.2. Substituting these values in the calculator, the area under the triangle will be equals to 24.81 centimeter squared. So the area of the shaded region will be the difference of the two areas that we found. So the shaded region will be equals to 36.18 for the sector minus 24.81 for the triangle. The difference will be 11.4 centimeters squared for the area of the shaded region. In question 8, the equation of a circle is x squared plus y squared plus ax plus by minus 12 equals to 0. The points A11 and B2, minus 6 lie on the circle. In part A, we have to find the values of A and B and then find the coordinates of the center of the circle. Now, to find the values of A and B, we'll substitute the coordinates A and B separately and then try and solve them simultaneously to find the values of A and B. So substituting point A, which is x1 and y1, this will become 1 plus 1 plus A plus B minus 12 equals to 0 using x equals to 1. Simplifying this, we'll get A plus B is equals to 12. We'll take 12 on the other side and this will be equals to 12 minus 2. So the first equation will be A plus B equals to 10. Substituting A in place of x2 and y equals to minus 6. So this will become 2 squared plus minus 6 whole squared plus A into x, so that will become a 2a plus b into y, so that will become minus 6 into y minus 12 equals to 0. So this will be 4 plus 36 plus 2a plus, so this will be a minus 6 and this is a b up here. So this is a minus 6b minus 12 equals to 0. Simplifying, we'll get 2a minus 6b is equals to 12 minus 36 minus 4. So this will be 2a minus 6b is equals to 12 minus 36 is minus 24, minus 24 minus 4 is minus 28. Now solving the two equations simultaneously to find the value of a and b. So the first equation was a plus b equals to 10. We can substitute this in the calculator to get the value of a and b, or we can just use the elimination method, multiplying this equation by minus 2 and this by 1. We will get minus 2a minus 2b is equals to minus 20. 2a and 2a minus 2a will cancel. Minus 6b minus 2b is minus 8b. And minus 28 minus 20 will be minus 48. So the value of b will be equals to 6. Once we have the value of b as 6, we can use the equation a plus b equals to 10 to find the value of a. So a plus 6 is equals to 10. The value of a will be equals to 4. Now we also have to find the coordinates of the center of the circle. First, we can write an equation as x squared plus y squared. So that was a plus ax. So a is 4. So this will become plus 4x. B was positive 6. So the equation will become plus 6y minus 12 equals to 0. Now comparing this with the equation of a circle. So the equation of a circle general form is given as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equals to 0. So as the coefficient of x is minus 2a and over here it's 4. So we'll write minus 2a equals to 4 and the value of a will be equals to minus 2. Y, the coefficient of y is minus 2b. So minus 2b will be equals to positive 6. So the value of b will be equals to minus 3. And in the general form of the equation of a circle, a and b are the coordinates of the center of the circle. So once we have the values of a and b, we can say that minus 2, comma minus 3 are the coordinates of the center of the circle. In part B, it is saying that find the equation of the tangent to the circle at point A, giving your answer in the form px plus qy equals to k. Now we know that if we have a circle, and we have a tangent, so it makes a right angle with the center. The coordinates of the center that we had were minus 2 and minus 3, and the coordinates of A was given as 1, comma 1. So first finding the gradient of A and the center. So the gradient of AC will be y2 minus y1. So 1 minus 3 divided by 1 minus minus 2. This will be equals to 4 upon 3, which means that the gradient of the tangent will be equals to the negative reciprocal, which is minus 3 upon 4. Now, as you're finding the equation at the point A, equation of the tangent point A, so we'll use the coordinates of point A, which is 1 and 1. So we write y minus 1 is equals to minus 3 upon 4 into x minus 1. Cross multiplying, we'll get 4y minus 4 is equals to minus 3x plus 3. Now we have to give our answer in the form px plus qy equals to k. So we'll put x and y together. So we'll write 4x. 4y plus 3x is equals to 3 plus 4. So the final answer will be 4y plus 3x is equals to 7 for the equation of the tangent to the circle at point A. In question 9, the equation of a curve is y equals to 3x plus 1 minus 4 into 3x plus 1 to the power half for x greater than negative 1 upon 3. We have to find dy dx and d square y upon dx squared. So in the first step, finding dy dx. So the derivative of 3x will become 3. 1 is a constant, so it will become a 0. To differentiate 4 into 3x plus 1 to the power half, we'll multiply half by minus 4. So 4 will multiply by half. 3x plus 1 will remain as it is, and the power will decrease by 1. So this will become minus 1 upon 2. We can simplify it to write it as dy by dx is equals to 3 minus 2 into 3x plus 1 to the power minus 1 upon 2. And we also multiplied by the derivative of 3x plus 1, which is 3. So multiplying it by 3, the final answer will be 3 minus 6 into 3x plus 1 to the power minus half. To find d square y upon dx square, we differentiate dy dx again. So d square y upon dx square. So derivative of 3 will be 0. Minus half times minus 6 will become a plus 3. So minus half, minus 6 times minus half, bracket 3x plus 1. So minus 1 upon 2 minus 1 will become minus 3 upon 2 multiplied by 3. So this will be 2 1 times 2 3 times. Minus minus will cancel out. So the final answer will be 9 into 3x plus 1 to the power minus 3 upon 2. In part B, we have to find the coordinates of the stationary point of the curve and determine its nature. So as dy dx was 3 minus 6 into 3x plus 1 to the power minus 1 upon 2. At stationary point, dy dx is 0. So first we'll write that dy dx was equals to 3 minus 6 into 3x plus 1 to the power minus half. We'll put it equals to 0 and then find the value of x. So we'll write 0 is equals to 3 minus 6 into 3x plus 1 to the power minus half. Taking this on the other side, we can write it as 6 and keeping 3x plus 1 in the denominator to make the sign positive. This will become 6 upon 3x plus 1 to the power half is equals to 3. Cross multiplying, we'll get 6 upon 3 is equals to 3x plus 1 to the power half. Now taking the square on both the sides, so 3 ones and 3 twos will become 6. Now to get rid of the power 1 upon 2, we'll square both the sides. So this will become 4 is equals to 3x plus 1. So 3x will be equals to 3 and x will be equals to 1. Now as you have to find the coordinates, which means we'll also have to find the y value. So the equation was y equals to 3x plus 1. So the original equation was y equals to 3x plus 1 minus 4 into 3x plus 1 to the power. So it was to the power 1 upon 2. Substituting x equals to 1, we'll get y equals to 3 plus 1 minus 4 into 3. 1 times 3 plus 1 will become 4. Square root of 4 will be 2. So y will be equals to 4 minus 4 into 2. So the value of y will be 4 minus 8, which is minus 4. So the coordinates of the stationary point will be, so 4 minus 8 will become minus 4. So the coordinates of the stationary point will be 1 comma minus 4. And the last part, we have to determine the nature. So to determine the nature, we'll substitute this value of x in the double derivative that we found out, which was 9 into 3x plus 1 to the power minus 3 upon 2. So to find the nature of the stationary point, we will use the expression for d square y dx square, which was 9 into 3x plus 1 to the power minus 3 upon 2. Substituting x equals to 1, we'll get 9 into 3 into 1, which will become 3 plus 1 to the power minus 3 upon 2. So this will be 3 upon 4 to the power 3 upon 2. As this will be greater than 0, the nature will be a minimum point. In question 9, functions f and g are defined as f of x is 2x plus 1 and f upon 2x minus 1 and g of x is x squared plus 4. In part A, the diagram shows part of the curve y equals to f of x. We have to state the domain of f inverse. Now, to find the domain of f inverse, first we'll try and figure out the range of f of x. Now, from the graph, we can see that as this is the point y equals to 1, so the graph is above 1 and below 1, but it is not touching the line at y equals to 1. So we can say that as f of x is greater than 1 and f of x is less than 1, so the domain for f inverse will be x is greater than 1 and x is less than 1, as the range of f of x is the domain of f inverse. In part B, we have to find an expression for f inverse of x. Now, f of x was 2x plus 1 upon 2x minus 1. So first we'll write it as y equals to 2x plus 1 upon 2x minus 1. Now exchanging x and y, we'll get x equals to 2y plus 1 upon 2y minus 1. Cross multiplying, this will become 2xy minus x is equals to 2y plus 1. Now making y the subject, we'll write it as 2xy minus 2y is equals to 1 plus x. And then taking y common, this will be 2x minus 2 equals to 1 plus x. Finally, y will be equals to 1 plus x upon 2x minus 2. So we can write f inverse of x as 1 plus x upon 2x minus 2. In part C, it is asking us to find g f inverse of 3. So the function g is x squared plus 4. So as g is for g f inverse of 3, so g is x squared plus 4. In place of x, we'll now replace it with the function f inverse. So f inverse is 1 plus x upon 2x minus 2 whole squared plus 4. And as the value of x, we have to substitute is 3. So we'll write it as 1 plus 3 upon 2 into 3 minus 2 whole squared plus 4. So 1 plus 3 will become a 4, and this will be 6 minus 2, which is 4 whole squared plus 4. So this will be 1 squared plus 4, which will be equals to 5. In part D, it is asking, explain why g inverse of x cannot be found. Now, as g of x was x squared plus 4, and the domain, which was x, was an element of real number. So if you have a quadratic curve, for it to have an inverse, it must be a one-to-one function. But as x is taking all the values of real numbers, so it means the function will not be one-to-one. So we'll write that as g of x is not one-to-one, that's why it cannot have an inverse. So we'll write as g of x is not one-to-one function. Now in part E, it says that show that 1 plus 2 upon 2x minus 1 can be expressed as 2x plus 1 upon 2x minus 1. So first we'll take the LCM, which will be 2x minus 1. 1 will multiply by 2x minus 1 plus 2. So minus 1 plus 2 will become a plus 1. So that will be 2x plus 1 upon 2x minus 1. Now in the second part, it says, hence find the area of the triangle enclosed by the tangent to the curve y equals to f of x at the point where x equals to 1 and the x and y axis. Now to understand this, we'll try and make a graph over here. So let's say if this is the graph and the tangent to the curve at the point, and this point is x equals to 1. So if I make a tangent over here like this at x equals to 1, to find the area enclosed, we'll have to first find the equation of the tangent, find the points at which it crosses the x and the y axis, and then use half base into height to find the area. So first, to find the equation of the tangent, we'll first find the gradient of the curve, which is the dy dx. So finding the dy dx, we can now use the form 1 plus 2x minus 1. We can use y equals to 1 plus 2 upon 2x minus 1. So using that, this will become, so derivative of 1 will become a 0. And to differentiate 2 upon 2x minus 1, we'll bring 2x minus 1 in the numerator as power minus 1. So minus 1 times 2 will become a minus 2 into 2x minus 1 to the power minus 2. Will decrease the power by 1 and multiplied by the derivative of 2x minus 1, which is 2. So the dy dx will be minus 4 minus 2 times 2, and then we can bring 2x minus 1 minus 2 in the denominator to make it a whole squared. Now we have the dy dx. Using x equals to 1, we'll be able to find the gradient. So the gradient will be minus 4 upon 2 into 1 minus 1. So that will be minus 4 upon 1, which is minus 4. Now we have the gradient. We need a point on the line. We already have x equals to 1. And now we need the value of y. So to find the value of y, we'll use the expression for y, which was y equals to 1 plus 2x minus 1. So y was equals to 1 plus 2 upon 2x minus 1. Substituting x equals to 1, we will get y equals to 1 plus 2 upon 2 minus 1. So this will be 1 plus 2 upon 1. So y will be equals to 3. So once we have the value of y, x and y and the gradient, we can now make the equation, which will be y minus. So we'll use the formula y minus y1 is equals to m into x minus x1. Y1 is 3, so this equation will become y minus 3 is equals to minus 4 into x minus 1. Now to find the points at which it crosses the x and the y axis. So for the x-axis, we'll use y equals to 0. And for the y-axis, where the tangent crosses the y-axis, we'll take x equals to 0. So substituting y equals to 0 into the equation, we'll get minus 3 is equals to minus 4x plus 4. Taking 4 on the other side, this will become minus 3 minus 4 equals to minus 4x. So minus 7 will be equals to minus 4x, and x will be equals to 7 upon 4. So this coordinate will become 7 upon 4 comma 0. To find the y value, we'll substitute x equals to 0. So this will become y minus 3 is equals to minus 4 into 0 minus 1. Y minus 3 will be equals to minus 4 into minus 1, which is a plus 4. And then y will be equals to 4 plus 3, which is equals to 7. So we have the y coordinate as 0 comma 7. Now we know that this point is 7 upon 4, the x value, and the y value is 7. So we can use that as the height. So the area will become half. So area will be equals to half into 7 into 7 upon 4. Simplifying this, the area will be 49 upon 8. In question 11, the function f is given by f of x is equals to 4 cos power 4x plus cos square x minus k for x is 0 to 2 pi, where k is a constant. In part A, given that k equals to 3, we have to find the exact solution of the equation f of x equals to 0. So the equation will be 4 cos 4x plus cos square of x, and in place of k, we'll write 3 equals to 0. Now to make this equation simpler, we can use a substitution like y equals to cos square of x, which means that y squared will be equals to cos 4 of x. So this equation will become 4y squared plus y minus 3 equals to 0. Solving this coordinate equation through our calculators or by midterm breaking. So using midterm breaking, if we cannot solve it with our calculators, this will become 4y squared plus 4y minus 3y minus 3 equals to 0. Taking 4y common, this will become y plus 1. Taking 3 common, this will become a y plus 1 equals to 0. So we'll get 4y minus 3 into y plus 1 equals to 0. So the values of y will be y equals to 3 upon 4 and y will be equals to minus 1. Now as y was equals to cos square of x, to find the value of cos x, we'll have to square root the value of y. As a square root of minus 1 is not possible, a square root of a negative number is not possible, so we'll not be using minus 1. Now taking y equals to 3 upon 4 is equals to cos square of x. We'll write it as cos of x will be equals to square root of 3 upon 4. Now taking cos inverse of 3 upon 4 in our calculators to get the basic angle, the basic angle will be cos inverse of square root of 3 upon 4. Now keeping in mind that this x values were given from 0 to 2 pi, we'll have to keep our calculators in the radian mode. So cos inverse of root 3 upon 4 will be equals to pi upon 6 in our calculators. Now, as a square root has a positive and negative sign both, so we'll be taking cos in all the quadrants as it can be a negative or a positive. we'll make pi upon 6 in all the quadrants. So we'll make pi upon 6 in the first, in the second quadrant, in the third quadrant, and in the fourth quadrant. Now to find the value of x, we'll be taking angles from the x-axis anti-clockwise. So the first value of x will be equals to pi upon 6. The second value will be pi minus, so this is the line of 180. So this will become pi minus pi upon 6. The third value will be pi plus 1 upon pi plus pi upon 6. So this will be pi plus pi upon 6. And the last value will be from here till here, which is 2 pi, which is 360 minus pi upon 6. Simplifying these values, we'll get x equals to pi upon 6. 6 pi minus pi upon 6 will become 5 pi upon 6. Then pi plus pi upon 6 is 7 pi upon 6. And finally, 2 pi minus pi will become 12 pi minus pi, 11 pi upon 6. So these will be the four values for x. In part B, it says that use a quadratic formula to show that when k is greater than 5, the equation f of x equals to 0 has no solutions. So f of x is equals to 4 cos to the power 4x plus cos square of x minus k. Now, if you apply the quadratic formula for, let's say, cos square of x, as we have a cos 4 over here, so the quadratic formula is minus b plus minus b squared minus 4ac upon 2a. So solving for cos square of x, we'll get cos square of x is equals to, so the b over here is a 1, so this is minus 1 plus minus b squared minus 4ac, so that will become 1 squared minus 4 into a is 4 and c is k upon 2 into 4. Simplifying this, we'll get minus 1 plus minus 1 minus 16k. And as this was a minus k, so this will become 1 plus 16k upon 8. Now we have to show that when k is greater than 5, the equation f of x equals to 0 has no solutions. Now if we substitute k equals to 5 in this formula, we'll get minus 1 plus minus 1 plus 16 times 5 upon 8. 16 times 5 is 80, so that will become 80 plus 1 is 81. So that will be minus 1 plus minus square root of 81 upon 8. So minus 1 plus minus square root of 81 is 9 upon 8. Now the two values will be minus 1 plus 9 upon 8 and minus 1 minus 9 upon 8. Now as the cos cannot be greater than 1 and we are getting minus 10 upon 8 up here, so this value will be ignored and we'll take cos square of x is equals to minus 1 plus 9 upon 8, which is equals to 1. Now, if we take any value greater than 5 into this in the square root will have a value greater than 9. And when we add it with negative 1 and divide by 8, the value will be greater than 1. As cos cannot be greater than 1 or less than minus 1, this basically proves that any value above k, the equation f of x above k equals to 5, the equation f of x is equals to 0 will have no solutions. So we can just simply say that as including values of k above 5, the cos square of x will be greater than, so cos square of x will be greater than 1 for k greater than 5. That's why there will be no solutions.